So in this session, we are going to discuss about unsupervised learning. So the clustering is known as unsupervised learning because in supervised learning, we start with label data. Whereas in clustering, we look at different aspect. We will look at similar groupings in the data. It's something like, for example, if you are in an organization, if you have customers, we look for some customer groupings and why those groups are. Similar to that, we can also think about the student in, graduates in the university, for undergraduates in the university. For example, we can look for their groupings. So looking for similar groups is very interesting problem, especially when you don't have label data. So sometimes we use this as the first stage before classification, because sometimes you start without any label data. So that case, we can use clustering as the starting point. So there are many different types of clusters are available. Like you can purely separate them into 3 different clusters, as you look at here in this example. So in this particular example, you can see we have the data points are starting from A to H. We have grouped into 3 different clusters, which means if you take a particular data point, it will belong to only one cluster. And this is what exactly we are going to look at in the first clustering algorithm. Secondly, sometimes some of the instances might belong to more than one cluster, which you will see in the second figure. So for example, if you take the instance G belongs to 2 clusters, this one, and this is the another one. And third one, sometimes we can talk about some probability values for G, for example, might belong to cluster 1 and 2, but not the third one. So likewise, you can give some, probability value, like the likelihoodness of being the instance G classified into these 3 different clusters. The last one is, instead of, you try to group them, you are trying to look at subclusters within the instances. So there are 2 types. For example, you can individually start with individual instances, then they can put into smaller clusters, and then by merging them, we can come to a bigger cluster. Or else you start with putting everything in a bigger cluster, and then you are separate into the smaller clusters. So this is called hierarchical clustering. So having said that, let's start with our first algorithm, which we call k-means clustering. Right. So in k-means, we are going to look for k clusters. Here, k is called a parameter. So the idea is we are going to look for cluster centers, and this will be iterative one, which means we start with initial cluster centers, and we keep on working until we get the desired numbers of clusters. So one of the things that we need to remember is we need to know how many clusters we need to have within the data set. So therefore, as I told you earlier, k is a parameter. And then we have to have a method of, deciding how we end up with the final clusters. So we can talk about some optimization technique where when we are going to say that that's n. For example, in k-means, we will iterate until the cluster centers will not change, right? And the idea is by doing so, we are going to assume that the instances, though the objects within the cluster, they are very similar. And And the other point is every cluster or every object will be assigned to a cluster. So let's start looking at the basic algorithm. So the first one is you start with k initial random cluster centers. So what it means, let's say you are going to decide to identify 3 clusters, then we will say k is 3. So when you say k is 3, we start with the 3 random cluster centers. And then what we do as the next step, we will take all the instances, the records, and we will see the closest cluster and we'll assign those instances to those clusters. So if you say k is 3, all our instances are put into one of these 3 cluster centers. Then once you do that process, what happens? Now you will get 3 clusters, right? You will get 3 clusters because initially you start with some random initial cluster centers. We assign each and every object, the instance, into these clusters. So after you finish this step, your data set is clustered into k cluster or k groups. And then what you do is you recalculate based on the assignment. And once you recalculate, now you get 3 or k, in this particular case, k new cluster centers. So you have to repeat, right? You assign all the objects to cluster and you calculate again like in earlier, calculated distance, and then you choose closest and simply we can move on if this is changing. So whenever it changes the cluster centers, we can recalculate the centroids. So this is repeated until there's no movement in the data set or in the instances. Let me briefly graphically show you what will happen. So in this particular case, we have, you can see this is in 2D plane. We have, let's say this is X and Y, right? And then this is X and Y. And then what will happen? Each of these data points we can represent in this case, red circles. So each of these red circles will be the object or the instance. And in this example, we assume that we are looking for 3 clusters. So we start with 3 random cluster centroids. So having said like this, now the next step is we want to assign them, right? So assigning means simply we look at the distance from each. So for example, if you look at from each instance, you calculate the distance to 3 different clusters. So you calculate the distance from here to here. So this is the, sorry. How can I undo this? Right, okay. So in this particular case, as I told you earlier, what you do, you calculate distance from each instance to the cluster center. So you calculate from here to here, and here to here, and here to here. And you know that this will belongs to the first one. So that means you allocate this, right, this instance into this cluster centroid. Similar to that, you can assign this is to this is to this, and so on, right? You can put them, right? Similar to that, you can again recalculate them, right? You can assign, depend on the distance, right? So once you do this, we know what will happen if you keep on assigning each of these data points into cluster centers. So it'll create 3 clusters. Now the issue is, now we know that originally our cluster center is here, but now since you know the clusters, you can recalculate. So this will be the new one here. In here, it will be somewhere here. And in this one, it will be somewhere here. So likewise, when you recalculate, it will readjust. Right. Now what will happen once you do that, the assignment, you recalculate. When you say recalculate, what happens? It will adjust. Now, again, you have to repeat the process, which means again, you start with the 3 cluster centers in our example and assign each of these instances to closest center. So in this one will be assigned to this will be here, this will be here, this will be here, this will be here, and so on. Similar to that, this will be aligned to this one is assigned to this one, and so on. So which means if you keep on doing this, so you get 3 clusters, and then when you recalculate, your new cluster centers looks like this. Right? So this is what will happen. And then hopefully once you come to a place, it won't change. And whenever you see it won't change, then we can stop at that point and we can say that these are the cluster centers, right? And then we know the 3 clusters. In this particular case, we have this cluster 1, we have another cluster 2, and this is 3. Because we have decided in the beginning, case 3. Right. Okay. Now, to discuss what happens here. So we can have a simple clustering technique, right? And then we can, it's very simple. And only thing is you need to know the number of clusters, which is K. And the final clusters, remember this is very sensitive, sometimes depend on our initial cluster centers. So therefore, sometimes there's no guarantee that you will get the global minimum here, right? So the idea is to avoid this one, what you could do is you can run the same algorithm for multiple times to get the best, cluster centers. Now, how do you say the cluster centers are the best? So what you can do is, since you calculate the distances, you can actually look for the smallest total square distance, right? And that's how we can decide whether whatever we selected is the best when you compare with other results. Okay, so I hope you got basic understanding of this. Let's move on to a simple example, right? So to show you how this works in a simple problem. So let's assume that we have given some points in the Euclidean space. So like you can think this is like 2 features or 2 data points. So having said that, and then let's say we are trying to assign these into 2 cluster centers. So if you want to assign them to 2 cluster centers, right? So we'll start with giving you a point. So 2 comma is the first initial cluster center. 3 comma 0 is the next cluster center. Right. Now let's see what will happen. So if you take this, and here are the data points. The first one is 1 comma 1. Let me put this as A. So this is A. right? And 2, comma 1, 2, comma 1, this is B, right? This is B. 2, comma 3, 2, comma 3, this is C. This is C. Then 4, comma 2 is D. 4, comma 2, this is D. Then 4, comma 4 is E. 4, comma 4 is E. Then 5, comma 4 is F. 5, comma 4 is F. So these are the data points. Now the point is we have two cluster centers, right? So let's say this is X, my first cluster center. Sorry, we'll go other way around. So this is 2, comma 4 and 3, comma 0. So 2, comma 4 means this one. Let me put this as X, the first cluster centroid. And then let me put this as Y, next cluster centroid. Okay, so the first step, if you go back, what we are trying to do is we'll start with K initial cluster centers. So in our example, it's already given. We are looking for 2 clusters. Then we have to partition the object into assign object to the closest centroid. So how do you know that which one is the best? Right? So can you say, if you take A, which is the closest cluster center? Is it X or Y? What do you think? So let's calculate the Euclidean distance with point A and X. So A is 1, the X value. For X, X value is 2. So we'll get the difference, square them. And then we have to sum it up. Then Y. So again, this is 1 minus. Then we have 1, 2, 3, 4 square. And then you can look at the square root of this. Yes, we can do that, right? So what about the next one? So the distance between A with Y then. Square root of 1 minus, that is 3 square, plus A is again 1 by 0 square root of this. Of course, since we already know, we did this with what you call, since you have done Python, maybe I can write a small Python function for this and it'll easier our burden, right? So let me take that and then it'll be easier for us to calculate. So let me find def, let's say, how do you say that? Okay, let's say D, and let me put the points. We'll say A, comma, then X, comma, Y. So we'll put it like this. The idea is we'll put A, X, and Y, and we will return, we'll calculate the distances. So what we can do is, right, distance let's say 1. Let me put D1 equals, let's assume that A is, we have a tuple, which, or we can say, we can take as, how do you say that? Another list, right? So in that particular case, we can get A naught minus X naught, and then square them, plus A1 minus X1, square them, and then take the square root. I will get 0.5. Right, that's the first distance. Let me show you how to put that in. Yes. Right, so this is the first distance. Sorry, I missed something. Okay, so this is the one. Okay, we have to have, so this is square plus this is square. And then see, okay, so I don't need this one, right? So this is D bar. So D2 is also the same. In D2, I'm going to get A naught minus Y naught plus A1 minus Y1. So we'll take, square them, and then we'll get the square root. I will get as a power of 0.5. So we get the distances and we'll calculate them. If D1 is less than D2, then, okay, we can say, okay, let's say print, right? If the D1 is then the closest one is X, and then we'll put the distance value, that is D1. Right? Else, we'll say print Y, we'll say D2. So if you want, you can print the two distances as well. But let's see. Let me see whether this is okay. Let's enter. Yes, I did it. Now let me give you the values we put. So I'm going to say D. My A is the first point, that is 1, 1, comma. Then X is 2, 4. And Y is, what is it? It's 3, 0. So if I put this is for point A. And as you have already said, A belongs to Y, right? So similar to that, let me try B. B is 2, 1. So let me put 2, 1. So again, B also to Y. Then let's put C. C is 2, 3. 2, 3. Now that is belong to X. Then D, that is 4, 2. So let me put 4, 2. Again, Y. Then we can go for E, that is 4, 4. again, it belongs to X, right? And then F that is 5, 4. So you can see now 3 points belongs to Y. So A, B, C is to X, and then we have Y. And then D is to Y, E to X, and F to again X. So which means if you go to the next one, you will notice that, okay, so we know. So that means we have ABD. ABD is belongs to Y, and this is belongs to X. So now you have to calculate the centroids. Now calculating centroid is basically you have to add all these values together. So which means we have A, centroid here, we have ABD is in 1, right? So when you say ABD, if you take X value, that is 1 plus 2 plus D, that is 4 divided by 3. And then Y values, 1 plus 2 divided by 3, right? So this is the first centroid, which means this will become somewhere down here because this is 6, 7 divided by 2. Sorry, 3, comma, this is 4 divided by 3. Right? So that's 7 divided by 3 means 2.33. And then the other one is 1.33. So if you go back to the next one, so assume that here we have 2.33 and 1.3. This is, let me say, Y1. Earlier it was X. So let me put this is X1. So X1, for example, you can calculate again like in early. So Y1 is 2.33. X1, these 3 belongs to X1. So which means the value is X1 will be X value 2 plus 4 plus 5 divided by 3. And then Y values 3 plus 4 plus 4 divided by 3, which is 9, 11 divided by 3. And then this is 8, again 11 divided by 3, which is 3.66, right? Or 67, you can see 3.67. That's true, right? So 3.67, 3.67. Right. So now you have to repeat again, right? So the new value X1 is, let me say 3.67, let's say, and then we have 3.67. So let's go back again, calculate. So I'm going to use the same function. So now let's start with the first one. I will take starting from here. So now the X value has changed. So that is 3.67, 3.67, and this is 2.33, and this is 1.33. So it says now A belongs to Y, this case Y1, right? And then let's take the second one. that is, we have 2, 1. B is also to Y. Then we'll get C. It's 2, 3. So 2, 3, that is C. That is also belong to Y this time. Now let's calculate for E. Sorry, D. D will be 4, 2. This is 4, 2 belongs to X. Then 4, 4. And then 5, 4. Right. So you can see A, B, C belongs to Y. We mean Y1. And C, D, E belongs to X. So if you go back here, so this is the new, what has happened, A, B, C belongs to Y1, and D, E, F belongs to X1 when you calculate the distances. So now that you have calculated the distances, again, now you can calculate the centroids. So for example, X, let's say 2, it will be now, X values are 4 plus 4 plus 5, 4 plus 4 plus 5 divided by 3. And then X value, sorry, Y values 2 plus 4 plus 4 divided by 3, which is 11 divided by 3. Sorry, 8 plus 5. That is 30. And this is 10 divided by 3. So the new centroid, when you re-adjust, so this will be 4.33. This is 3.33. So 4.33 means 4.3 somewhere here. And then we have 3.3. So somewhere here will be our next cluster centroid. Similar to that, if you calculate for Y1, if you readjust, so when you get the centroid value based on ABC, you should get 1.67 somewhere here. And then again 1.67, so which is somewhere here. So these are the next centroids. So this is the next centroid. But if you try to, again, if you try to repeat assignments, if you look at it, there won't be any changes because it'll be the same. No changes in the assignment. So therefore, we can consider this as a final cluster centers. And this is the outcome of our clustering algorithm, which says, okay, these are the centers. So, and then you can get the assignment as well. Right. Any questions on this? No questions? Okay. So now that we have discussed the idea, let me give you the quality of the cluster. So the quality of the cluster, usually what it means, we want to know uh, how good those clusters are. So simply, if when you calculate the cluster centroid and distance among the instances with the cluster centroid, and when you get the sum it up, uh, what you get is called sum of squared error, right? So, so that can be used because smaller the better, smaller the value, we can say the clusters are the better. So that's how we are going to handle it. Right. Any questions? Okay, now let me show you how we may have done this in Weka as well. So let me start looking at Weka. Okay, so I'm going to open Weka, and then you have to load a data set. Right. So I'm going to choose Explorer. Right. And this is what we are going to get. And you have seen that we are going to open some data sets and see whether we can use these to explain how the clusters are selected. So I'm going to choose C program files, Weka, data, and let me select, there's a data set called iris dataset. Okay, so if you look at the iris dataset, you can see, right, this dataset is about classifying or identifying three different types of flowers. So when I click class, you can see here, there are three types of flowers: Iris setosa, versicolor, and virginica. And if you try to visualize, you can also visualize based on the data sets. So when you click, you can notice that since we have selected the class, you can see there's a one group of data points and the other two also in two different colors, but there are some overlappings. This is what normally you will see. Now, this is not the data set what I want. I'm going to remove this. So I'm going to click class and I will remove. Right now, we don't know what we have, but we have a numerical data set, which is ideal for clustering. So let's assume that we don't have labels. So that's assumption. So when you want to perform cluster, you have to go to the cluster, tab, right? We'll go to cluster. But before that, can you repeat the same and let me know whether you are up to this point? So let me explain the steps one more time, starting from the beginning. So I'm going to close wake up. Right. So start wake up. Please follow with me. So I'm going to start wake up, my version. Okay. Then I'm going to choose Explorer. So I'm going to click Explorer. So under the Explorer, first thing is we are going to open a data set. So I'm going to click open here. Then I have to find some data. So I'll go inside the C drive. Under the C drive, I'll go to program files. Then I'm going to select the Weka version. Double click on it. Double click on the data and select this iris. There are two versions, iris 2D and iris. Click on iris and then I'll click open. Okay, if you are finished up to this point, just let me know. The next thing what I said was, let's remove the class because right now this is a label data set. So I'm going to remove this. I will click on class. Then I will remove it. And we left with 4 attributes: sepal length, sepal width, petal length, and petal width. Clustering, right? So I will go to cluster tab. So I will go to cluster. And under the cluster tab, there are many clustering algorithms. And I'm going to select simple k-means cluster. So click on simple k-means. Next one, we need to decide on the k value. So there's a place called number of clusters. I'm going to put 3. Instead of 2, I will put number of clusters into 3. And I will click OK. Then we'll say start. Done up to this point. Okay, now let's try to understand, right, what is given here. So it says number of iterations are 6, which means how many times you did it to get the final cluster, right? And Veka says that it had run 6 times, 6 iterations completed. Then here they will list the initial cluster point. So there are 3 clusters. We said K is 3. Therefore, these are the starting points. These are the starting points. Right? So the cluster centers, we had 4 attributes. So you can see 4 components. Then what happens? Once you start with this, each of these instances will assign to these cluster centers, and then you revise the cluster center. That's what we did, right? So here we have values. And these are the cluster centroids. When you take the average of the instances within the cluster center, this is how it look like. Then cluster 1, and then cluster 2. So this is the outcome of clustering algorithm. And then you can see within some squared error is given how closely match our solution. So we put it like this. Right. Any questions? To show you that what happens when you change number of keys. So let me put number of clusters to 2. And then if you run, let me rerun. So you can notice that here the squared error is 6.99. Let me say 7. And when you say 2 clusters, it's 12. Which looks like this is much better, right? 3 is better because you have a small squared error, which indicates that your clusters are very close to the clusters endpoints, right? Similar to that, if you take this and let's say number of clusters, let me put 3. So what I said was change it to clusters to 4. See what happens. Okay, good. I'm getting answers from the others as well, but just check, right? What if you change K? So let me put change K. So it's 4. Let me start, right? So you see, according to that measurement, you can notice that the average within that is 5.5. Okay, let's move on to the next one. Thank you for sharing your answers. So the next point is I would like to introduce another clustering algorithm. This is called hierarchical clustering, which means you can either start with a single cluster or you can create one cluster for each instance. So this is known as agglomerative or divisive. What do you mean by agglomerative? It means we are using bottom-up strategy, which means individual instances. We assume that they are the clusters and iteratively we will merge them. Next, a divisive hierarchical clustering, which means you start from top to bottom, you start, and then you are going to divide based on the hierarchical nature of the place. Right. Now, how it works, before that, I will explain the use of wake-up. You go to cluster. And you can select hierarchical cluster. Right now, I'm not going to change anything. So let me put the number of clusters as 3. You don't have to do this, but this is easier. So let me start. And here are the clusters. And then one thing is you can visualize this. Now this visualization show you how each of individual instances are put into a single cluster. So let me close everything and start from the beginning. Huh? Right. So let me start from Veka. And what I'm going to show you is hierarchical clustering. Hierarchical clustering means there are 2 ways of cluster them. You can start from top to bottom or bottom to top, right? So in this particular case, I'm going to open a data set. Before that, I'll open Explorer. And with that, I'm going to open up a file. Any data set might work, but naturally, since the calculations, I told you to select a number with decimal point. So I go to Veka and data. And then to illustrate my problem, I got iris and I'll remove class because unspoils learning. Now go to cluster tab, click choose. We select hierarchical clustering and you can put number of clusters you are seeking. So let me put 3 because I originally know that it's 3. And then if you want to visualize, right click, visualize 3. And this is a visualization for the data set. Right. Now let me explain how this cluster works actually. Although we got the diagram, we didn't discuss how actually it happens. Let me explain how we can create clusters. Now, one of the things is what we get, the diagram that we have seen is called dendrogram, right? And what dendrogram shows us is all the cluster data points. So the idea is you don't need to know how many clusters you need here, although we specified it. This is, although we said in the beginning, it not necessarily know the number of clusters, which is relief for us compared to k-means cluster rate. So as I told you earlier, you can work on two directions. Either you can merge them or you can split them. So two main strategies. One is agglomerative, which is bottom up. That means you start from individual data points and combine them. Or it's called divisive, which means you start with a single cluster and you separate them. And under that, you need to decide when to combine two instances together to make a cluster, or like combine smaller clusters to bigger clusters. There are multiple ways. We call single, complete, average, Ward's method. And there are plenty of applications you can think of. So let me explain with agglomerative clustering. That means you start with individual data points. And then let's say we combine and finally we get a single cluster. So idea is you start each object or the record as a single cluster. And then you identify a pair of clusters with a small linkage distance. I will explain what those means. And then you update the distance matrix to reflect the distance between the new cluster and the original. And you do this until all the objects will be in a single cluster. Okay, to explain this, I will take this example, right? Take a screenshot of this because we need this to understand. Or maybe I will explain. The first one I'm going to explain is single linkage. Single linkage means you are going to get the closest distance, right? Let me explain what closest distance means. For the time being, it's like this. So we will take, for example, these are the distances. So these are 4 points. So let's assume you have 4 data points and these are the distances. Can you tell me, okay, for example, this one means distance between A comma B. Remember the notation we discussed earlier? It's distance between A comma B. Similar to that, this one is distance between C comma D. Initially, we start individual cluster centers, right? So that means initially we have A, B, C, D. They are individual data points. They are individual. Now, can you tell me, by looking at the distances, which distance is the smallest among the two? The single linkage means you look for the smallest distance among the instances. Yes. Which of the 2 points are the closest? Yes. Smallest distance is between which 2 points?
A and B.
Exactly. Between A and B. So what we can do is, as a second step, this is the first step, you treat them individually. And you are going to combine A, B, right? And C and D. Now it becomes 3 clusters. The distance between A and B was 1. So this is the decision we made to merge them. So if I draw the instances, we can put it like this. We can say, okay, let me erase them first. So this part we have done. Okay, let me have A, B, C, D. Individually you have started by the distance of 1. So let's assume that AB connected now with the distance of 1. We'll say D equals 1. Now what happens? This matrix we need to update. So let's update the matrix, because now what we have is we have right, we have AB in a one cluster, C in another cluster, D is another cluster. Then what is the distance between A and B and A and B? So this should be, anyway, should be 0, right? Okay, now when you're filling this one, you have to be very careful, because we have 2 points here, we have 1 point here. So now we have two distance AC and BC. So when you look at AC, BC, you have to look at the smaller distance. What is AC? AC is 4. Then AC is 4, BC is 2. So therefore we put 2 here because we take the smallest distance. Then AB with D, we have AD. So AD is 5, BD is 6. So this is 5. This is how we are going to fill. So then C, it will be the same. So I will put 0 here. So what is the value here? Between C and D, that is 3. Then we have D. So between D and D is 0. So now, once you combine, our matrix is updated. Now, when you calculate, when you want to merge now, the next time, you have to merge another 2. When you look at the distances, which one has the smallest distance? Which 2 clusters has the smallest distance? Yes. Can you tell me? Can one of you tell me? Now we decided, based on this distance metric, we decided to merge A and B because A and B is the smallest. Then update our distance metric. And then now we have to look at the closest one. It will be A, B, and C, isn't it? Yes, agree. So now what we have to do is we are going to merge A, B, and C. The reason is distance between, we have A, B, and C, but we know that B comma C was 2. So that was the reason. So that means now we are going to merge AB with C with the distance of 2. Can somebody tell me the third one? What happens in the third one? Now our distance metric will be merged. Now we have A, B, C as a single cluster, and we have D. And again, A, B, C, right? And then we have D. So this is how we will have now after, merging A, B, and C. So this will be 0. This will be between D to D is 0. So what is the value? Should come here. So look at distance AD. AD is 5. Then BD, that is 6. Then, yes, CD is 3. So this will be 3 there. So now can you tell me which of the two clusters we have to merge? We have to merge these two. So we can say we have A, B, C, D, because distance between C comma D, that equals to 3. So now what happens? ABC is here, will merge with D with the distance of D equals 3. And that's how we got the dentagram. Right. Any questions? Is it clear to you? If it is not clear, just let me know. I can explain. Are we clear up to this point? No questions? Okay. So I have listed here how distance were calculated, right? So as you can see, this is what we have discussed, single linkage. When you have two clusters, you calculate the distance between the two nearest instances. And that's what we are getting as a dendrogram. So in this one, we are going to talk about how the complete linkage works. So in complete linkage, it's the maximum distances we have to discuss. So I will give you the answer, but let me show you how we calculate the distances. So like in previous one, we calculate A, B, C, D, right? And then when you calculate the distances, you get the maximum distance. Max means within the class, the smallest, right? Right now, we have been given this information. A comma B is 1. So since that's the smallest, you merge them. The next one is you calculate the distance between AB, AC, AD, BC, BD, and CD. And you will notice that this will give you the minimum distance. But the among, we calculate the max. So CD is 3. Okay, so let me update this and show you. Otherwise, you might not understand this one. So if you go back in our matrix, it will be like this, right? And the second time when we want to calculate, what do you mean by second time? First, you can look at merging A and B. The second one will be now what we have is A, B together. And then you have C separately and D separately. So again, A comma B, C, and you have D. Right. Now here it will be 0. Now calculate from here the distance between AC and BC. So distance between AC and BC. Earlier we have taken 2. Now you are taken as 4. Why 4? You get the maximum distance among. That means complete linkage. Similar to that, check these two. Between AD and BD. AD is 5, BD is 6. So this will be 6. This will be 6. Similar to that, you can put 0 here. the distance between C and D is, that is 3. And this is how it look like. Now, when you look at this, now take the minimum, that is C and D. So that's why we combine both CD together. So you combine CD because distance is 3. So therefore, AB connect with the distance is 1, CD connect with the distance is 3. Now what happens next? You combine these two, right? So what happens? The updated data points will be, so you have AB and then you have CD. AB, CD. So this is 0 and this is 0. Now look at the max value. ACAD. We have to look for ACAD. So we have to calculate AC. We have AC, BD. AC, so now you can see we are merging these two. Now you calculate the distance from the groups, but find the maximum. So AC is this. Let me check. Right? So we have AC. Then we have ACAD. ACAD. Then BCBD. BCBD. We'll get the max. So therefore, so this will be 6. Now that we have 6 here, right? Now that you have 6 here, so you merge them with the distance of 6. So that's how we performs clustering. So we discussed 2 clustering techniques. One is K-means, second one is hierarchical. Okay, so with this one, we conclude the clustering part. I have 2 more things to discuss. That is classification and association rules, and then implementation in Python. But I think we'll have a break and then meet again 3 o'clock to discuss or continue our session from 3 to 5. Thank you. We'll meet again 3.